So what are conductors and insulators? This is very important for us to understand because this is key difference point between metals and non-metals. Electricity can be conducted if they have either free electrons or free moving ions. The electro word comes from electricity. So it has something to do with electricity for sure. Then an electric current is passed through a molten ionic compound. The compound decomposes or breaks down. Hello and welcome back, students. So this is going to be your part 2 of electrochemistry. If you have not watched the part 1, then go check that out. It's going to be very basic. So you have to watch part 1 first before coming to this video, and you will find the link in the description box below. If you have any problem, then you can comment down below. I'll get back to you, and show your appreciation by liking the video, sharing it with your friends and family, whoever needs it, and subscribing to our channel. So let's get started. So this is going to be very important part of electrochemistry because we are covering many topics in this particular video. So make sure that you are carrying your notebook and your pen with you so that you can note down the important points. Okay, so let's first check what all topics we are going to cover in this particular video. Okay, so first we are going to talk about electrolysis of molten lead bromide. Molten lead bromide is PbBr2. Okay. Then we'll talk about electrolysis of some molten salts. Okay. Then electrolysis of dilute sulfuric acid. Dilute sulfuric acid is H2SO4. Next is we'll try to understand how is electrolysis of concentrated aqueous sodium chloride takes place. Okay. Sodium chloride is nothing but NaCl. Then we'll talk about the rules for ions discharge at the electrodes. There are two electrodes. We have already discussed about the basic parts in the first video. So there are two electrodes, cathode and anode. So what type of ion will be discharged? So those rules will be discussed in this particular topic. Then we'll understand and we'll try to predict that what product will be formed at particular electrode during electrolysis. Okay. Then by the end of the video, we will also study about the electrolysis of copper to sulfate when we use graphite electrode and when we use copper electrode. Okay, so let's get quickly started without wasting any more time. Okay, so the first topic is electrolysis of lead to bromide. Okay, molten. So before we get into the theory part, let's first check out the diagram. So this is the electrolysis or the setup of wherein we have to do the electrolysis of molten lead bromide. So lead bromide is a metal and non-metal which combines together to form an ionic compound. Okay, this first thing you should know. PbBr2 is nothing but an ionic compound. And from the previous part, we already know that a solid ionic compound cannot conduct electricity, right? Or we can say that we have to either melt it or dissolve it so that it can conduct electricity, right? It is an electrolyte. It is an example of electrolyte. So PbBr2, first thing is that when we add PbBr2 in our setup, what do? We add it and then we have to melt it. So we provide temperature or heat. Okay, this is temperature or heat continuously. So that what happens? This PbBr2 gets molten. Okay, so what is present here? Molten lead bromide. Molten PbBr2. Right? Then what happens? There are two electrodes. What electrodes are we using? Graphite electrode or platinum electrode. Why? Because they are inert in nature. It means that they will not react with the electrolyte. Right? Then power supply is there. We should know that positive of the power supply should be connected to the positive electrode, or that electrode becomes positive. Right? So positive electrode is known as anode. We have already discussed one mnemonic, PANIC. This mnemonic I told you in the previous class, which states that positive is anode and negative is cathode. Okay, this you should know. Now what happens? There are two types of ions present in this particular electrolyte. Okay, what are these ions? There are Pb plus 2 ions and then there are Br minus ions. So this Pb plus 2, because it is a positive ion, I can say that this is a cation, right? And this is a anion. Okay, and we know that cation will move towards cathode because opposite charge attracts. Okay, So I can say that Pb plus 2 will be deposited near cathode because it is negatively charged electrode, and Br minus ions, which are negative ions, will be deposited or will be present near your anode. Okay, so can I write this reaction like this? At anode, Br minus comes, okay, and what happens? It loses its electrons. Here in this diagram you can see that Br minus comes, and because this anode is positively charged, it means that it is electron deficient. Hence this Br minus loses its electrons to become a neutral species, which is Br, right, which is Br. So if I have to write the reaction, what is happening at anode, I will write Br minus comes, okay, and then what happens? It loses electrons on anode, okay, and it becomes Br. Okay, if I will write it for 2 Br anions and then add this reaction, I can get 2 Br minus gives 2 electrons and it forms Br2, okay, because Br is a diatomic molecule, okay. So Br combines to form a bromine gas, okay. So reddish brown bromine gas will be evolved at anode. Why? Because bromine is losing electron. Now if you remember from the previous part, I gave you one more mnemonic, which is OIL RIG. What does it mean? It means oxidation is loss of electron and reduction is gain of electron, right? Here loss of electron is taking place because Br minus is losing its electron to anode, okay. So I can say oxidation is taking place. Oxidation at anode is taking place. So this is very important. This is how we write the half equation, okay. So anode half equation will be Br minus gives Br plus electron, okay. This is oxidation when it is losing electron. Similarly, if we'll talk about what is happening at cathode, now because cathode is a negatively charged electrode, so positive ions will come towards it, okay, and they will gain electrons from it because these positive charge ions are electron deficient. It needs electron to get neutralized, right? So what is happening? Look at this diagram. This is important. So cathode is negatively charged electrode. It means it is already rich in electrons, okay. Why? Because it is present at the negative terminal of the battery, so all the electrons are pumped in the cathode, right? Now because cathode is electron rich, so positively charged species will come and they will gain electron from it, and gaining electron is known as reduction, right? Gaining electron is known as reduction. So at cathode, reduction of lead ions take place, okay. It means lead, so Pb plus 2. Pb plus 2, it means it needs 2 more electrons, so it will gain 2 electrons from the cathode and then it will become a neutral species, which is Pb, okay. This is the reaction. See here, this is the reaction which will take place at cathode, okay, or we can say this is cathode half reaction or cathode half equation, okay, which is nothing but reduction of lead, okay. Now lead, when lead will get deposited over here, we can see gray color metal is being deposited because color of lead is gray, and bromine gas present over here, it means reddish brown gas we can see, okay, while the experiment is taking place. Now let's check out the theory, okay. So the theory says, let's read it one by one, and if you wish to write the important points from this, you may do so. So lead to bromide heated in a beaker, it will turn molten, allowing ions to be free. We know that solid ionic compound cannot conduct electricity, so therefore we melt it, okay. Melted means they can now the ions can move freely, right? Second, electric charge positive ions, cation in the electrolyte, move towards cathode. We know Cc, okay. This mnemonic also we talked about. Cation starts with C and it is attracted by cathode, which also starts with C, okay. And anion, which is a negative charge species, starts with A and will be attracted by anode. It starts with A, okay, which is a positive electrode, okay, and anion is a negative ion, so opposite. Next, 2 graphite rods are electrodes, okay. 2, we all know that, connected to a power pack or battery, the electrons move from anode, okay, this we already know. So where is electron actually moving from? Negative terminal to the battery, then cathode. then anode, and then back to the battery, okay, to the positive terminal of the battery. Next, turned on power pack or battery allow the electrolysis to take place. Okay, so for the experiment to actually take place, we have to first turn on the battery. Obviously, that's how the electrons will start moving. Okay, next, negative bromide ions move to the positive electrode. We know that, right? And each loses one electron to form bromine molecule. Now, how will we know that if bromine molecule is found over here? Because there will be reddish brown color gas which will tell us that yes, it is bubbling of bromine gas. Okay, this is the test. There is a bubbling at the anode as red brown bromine gas is given off, right? Next is positive lead ions move to the negative electrode because it is positive, so it will move towards negative and gain electron to form a gray lead metal. This is what I told you. Okay, so the movement of ions here means metal will always be formed at cathode, and the non-metal which is over here is bromine gas. Okay, let me write here. Bromine gas is the non-metal in this particular electrolysis. Here it will always be formed at anode. Okay, so this you should remember. I'm marking a star over here so that you can write it. This is important. The metal will always be formed at cathode, which is a negative electrode, and the non-metal is always formed at the anode. Okay, one exception is there, which is hydrogen. So metal, or if hydrogen is present, which we will see in the later part of this particular video, will always be formed at cathode, and at anode non-metal will be formed. And this is the diagram. Now take a minute and you can write down this. I think this part is enough for you to actually understand the working, okay, because we have written all the important reactions at both the sites with what actually is happening. Okay, so take a minute and write this thing down. I hope you have understood this. Now let's move to electrolysis of molten salts. Okay, so what really happened? For example, PbBr2 we have already done. Okay, so product at cathode, which is a negative electrode, Pb was deposited, right? Because Pb is a metal, lead is a metal, right? And at anode what happens? Br is present, right? And if I have to write the cathode half equation, which is this, and anode half equation, so how will we write? We have already done this. Okay, now let's try for some other salts also. So if you have sodium chloride, in this we know that sodium is a metal, and if it is a metal, it will be positively charged ion, and it is a positive charged ion, so it will go to negative electrode. Okay, and what happens at negative electrode? Na plus the positive electrode plus one electron. What is happening here? Because it is gaining electron, so reduction is taking place. Let me write here that at cathode reduction takes place, means gain of electron. Okay, and how will you remember this? By that mnemonic which I told you, oil trig. Okay, which means oxidation is loss of electron and reduction is gain of electron. And anode half equation is nothing but your oxidation. Oxidation means loss of electron. Okay, so over here for this particular example, how will we complete this table? Na plus plus 1 electron gives Na, and the non-metal over here is chlorine, right? So for chlorine, what will we write? 2Cl minus give Cl2 plus 2 electron, right? It is giving electron, right? It is giving electron. So I can say, okay, so I can say that it is getting neutralized after donating electron, right? For aluminium oxide, what can we write? So Al plus 3 electrons give Al. At the end of the day, after oxidation or reduction, whatever is happening, the species should be neutral. Okay, after gaining electron or losing electron, it should be neutral. Then what is the non-matter over here? Oxygen. Okay, so what will happen? 2O minus gives O2 plus 2 electrons. So over here, oxygen gas will be produced. Next is your copper 2 bromide CuBr2. Over here, copper is your metal, so it will be deposited at the negative electrode, which is nothing but your cathode, and bromine is a non-metal which will be deposited at anode, which is nothing but your positive electrode. How will we write the reaction? So metal will be written at this cathode half equation, or maybe a reduction will happen with copper. So Cu plus 2 electrons if C. Okay, this will be the proper reaction for this. Then for bromine, how will we write? 2 Br minus gives 2 electron plus Br2 gas. Over here also bromine gas will be formed. I hope this is clear. Again, I am summarizing it one more time for you. If there is a metal or hydrogen, then it will always be found at cathode. Okay, and what will happen at cathode? At cathode, reduction takes place. What is reduction? Gain of electron. Okay, so metals or hydrogen will gain electron at cathode. Okay, and what will happen with non-metals? Non-metals will go to the anode and oxidation will take place. What is oxidation? Oxidation is loss of electron. I hope this is clear. Please take a minute and write this thing. Okay, now let's move on. Now let's talk about electrolysis of dilute sulfuric acid. So what is sulfuric acid? Sulfuric acid is H2SO4. We know that, right? Now what is happening in this? We use a different apparatus. So this apparatus is usually known as Hofmann voltameter. Okay, so this can be used for the electrolysis of dilute sulfuric acid. Now why are we using this particular apparatus? Why we are not using the simple electrolytic cell? Because here two gases will be formed and we need these two gases to be separate so that we can test the gases. Hence, for the gases to be separate, we use this particular apparatus. Right? So let's read. Electrolysis of dilute sulfuric acid, as it keeps the gases produced separate effectively. This experiment is electrolysis of water. Okay, you can also say that this is an electrolysis of water. So if I have to write the reaction for water, what do? Water breaks down into H2 and O2, right? If I'll add 2 over here, now the reaction is balanced. In water electrolysis also, what is happening? Hydrogen gas and oxygen gas is producing. And in H2SO4 also, we will notice that both of these gases will be produced. Hence, it is said that this experiment is also termed as electrolysis of water. Now, let's check what is really happening. So, we are adding H2SO4 in water. Okay, in water. Now, H2SO4 will break down into its ions as H plus SO4 minus 2. Right? These are the ions it will produce if it will dissociate into its ion. And for H2, I already told you H2 and O2 will be produced. Now, tell me H plus and O minus 2. H2. Okay. Now tell me what all cations can we see here? Cations are nothing but positively charged. So we can see H plus. Okay, H plus is common. So we can say that only one type of cation will be present, which is H plus. And if only one type of cation is present, hence this H plus will move towards the negative electrode. And which is the negative electrode? Negative electrode is cathode. So where is cathode? Here. This is cathode. Your negative electrode. Okay, here your H plus will be produced. Can you see hydrogen gas produced? You can see the bubbles of hydrogen gas. Okay. Then what is happening? If we have to talk about anions or negatively charged ions, I can say two types of anions are present: sulfate and oxygen ion. Okay. So sulfate and your OH minus ions. Okay. Wait. Let me write down this reaction again for you. So H2O will break down as H plus OH minus. OH minus is nothing but hydroxide ion. Okay, hydroxide ion. Now we have to check that which anion will actually be present at anode. Okay, so here competition will be happening between sulfate ions and hydroxide ions. Okay, and whichever is greater in concentration, that will be deposited at your anode. Okay. So your OH minus ions will be actually depositing and your sulfate ions will not be depositing. So SO4 minus will be present over here only, right? And OH minus ions, when they will deposit at anode, what will happen? They will gain electron, okay, because they are negatively charged species. So they will gain, they will lose electron because they are negatively charged species, and hence they will become neutralized and electrons will be given out. So oxygen gas will be produced. Can you see the reaction? Oxidation half reaction. Oxygen gas will be produced. Can you see this much? Now, what questions are asked from this particular topic are, first they can ask that what is the ratio of hydrogen and oxygen which are produced, okay. So the ratio of H2 and O2 which is produced is 2:1, right? Twice the amount of hydrogen gas will be present, okay, got it. Now you can take a minute here. Okay, before that let's quickly read product at the positive electrode. So at positive electrode definitely negative ion will come, which I am saying that OH minus will come because the concentration is greater. So OH minus ions are attracted to the anode, they lose electrons and form the oxygen gas and water. So losing electrons means what? What do you mean by losing electrons? It means oxidation will take place. Okay, oxidation of hydroxide ions will take place, and in case of your negative electrode, what will happen? Positive ions will come. Here only one type of positive ion is present, which is H plus, no competition. So H plus ions are attracted to the cathode. The H plus ions gain electron because it is already positive. It means electron deficient species. It will gain electron and they will form hydrogen gas. Okay, the reaction is this, right? Gaining of electrons means what? Reduction is taking place, right? Now you can annotate this thing down. I hope this is clear and understood by you. If you have any doubt, then feel free to comment down below and I'll get back to you. So now let's move to very interesting examiner tips and tricks. So what is it about? So what type of gas is produced actually? So we can test that gas, okay? So for that we have to consider different experiments. Like for example, if chlorine gas is produced, then how will I know if the chlorine gas is produced or not? So there is this diagram for our better understanding. If chlorine gas is produced, what do? We bring a litmus paper near to it. It will change its color to red and then it will bleach to white color. Okay, as you can see in the diagram itself. And if you wish to write this, then you can do, if damp litmus paper is dipped into a sample of the gas, the chlorine gas, if it is a chlorine gas, it will turn red and then bleach to a white color. As you can see this white color, okay, it is bleached due to this chlorine gas. Okay, next is, if we have to check if the gas produces oxygen or not, then what do? We bring a glowing splint, okay, near to the mouth of the test tube, and if that glows or the flame reignites, then we can say that it is oxygen. Why? Because oxygen is a flammable gas, okay, it reignites the flame. So oxygen, if a glowing splint is dipped into a sample, as you can see we are bringing it near to the mouth of the test tube, then the splint will relight. Okay, then for the hydrogen, this is the third type of gas which we are checking the test. Okay, for hydrogen, what do? If we bring our glowing splint near to the mouth of the test tube from which the hydrogen gas is producing, what happens? We can hear a pop sound, okay, a squeaky pop sound will be heard. So if a lit splint is dipped into a sample of gas, then a squeaky pop will be heard. Okay, we can hear that particular sound, and hence we can say that hydrogen gas is evolved. Okay, you can please write this, it is very important and tests are often asked in your question papers also. Okay. Okay, I hope this is clear. Now let's move on to the next topic. So here we are going to discuss the electrolysis of concentrated sodium chloride. What is sodium chloride? It is NaCl. And because it is aqueous, it means it is dissolved in water, which is H2O. Now again, we have two very important compounds present in this particular part of the apparatus. So H2O will break down into its ions to produce H plus and hydroxide ion. Okay, and what about NaCl? NaCl will break down into its ions as Na plus Cl minus. Here we can see there are two type of cations, H plus and Na plus. Okay, so who will actually get deposited, that we will understand. And then there are two types of anion also, OH minus hydroxide anion, and one is halide ion, anion, which is your chloride ion. Okay, so what is going to happen here? First thing, let's talk about just cations first. These are the ions present. Okay, let's talk about the cations first. So if you have seen the reactivity series, which we will discuss in the coming slides, so in the reactivity series, whichever element is less reactive, that will get deposited in the at the cathode, okay, or at the negative electrode. We know metal and hydrogen get deposited at a cathode, okay. So Na plus or H plus, let me show you the reactivity series first, that we can understand well. Okay, here it is. So here we can see hydrogen is at the bottom, and where is our sodium? It is here, okay. Which is less reactive? Hydrogen is less reactive. So the metal or hydrogen, whatever is less reactive in the reactivity series, that will get deposited at the cathode, okay. So what will get deposited? Hydrogen will get deposited, and hydrogen is a cation. So how will I write? H plus, and cathode is negative charge, so it will gain electron. If it is gaining electron, basically reduction is taking place, okay. It will gain 1 electron and it will become H. Similarly, another H plus will gain 1 electron and it will become H. Now both these H becomes a molecules by forming a bond between them, because it is a diatomic gas, so H2 will be produced. And what was the test for H2? How will we know that if H2 gas is present? The test for H2, as we have already discussed in the previous, is we will bring a light splint, okay, near the mouth of the test tube, okay, in which hydrogen gas is present, and we can hear a squeaky pop sound, okay. That's when we know that it is hydrogen gas which is present, right? Next, let's talk about anions now. So I am using pink color for talking about anions here for this particular slide. Now we have two types of anions, halide and hydroxide, okay. So here in the heading itself, we can understand that it is a concentrated aqueous sodium chloride. Concentrated means sodium chloride is present at large amount, okay. So I can say the concentration of chloride ions is higher, okay. If the chloride ions are higher in concentration, it means chloride ions will go towards anode, and there they will lose their electron. Basically oxidation will happen with the chloride ions, not with the hydroxide ions, because the concentration of chloride is higher, okay. So chloride ions will move, as you can see it is present here. Chloride ions and anode, because it is a positively charged electrode, so chloride ions will give or lose its electron on this, okay. So Cl minus after giving 1 electron will become Cl. Again, if one more Cl minus will come, it will lose and become this. Then 2 Cl together, they will become Cl2 gas. And what is the test for Cl2 gas? We will bring a litmus paper near to it, and that will get that will first convert the or change the color into red, and then it will get bleached to white, okay. This is the test for chlorine, right? Next, so what can I say? That hydrogen gas will be present or will be evolved at cathode, and chloride gas will be evolved at anode, right? You can take a minute here, okay, before okay. So this is the reaction which I have already explained over here. This is the reduction half, this is oxidation half. If we have to write the overall reaction, then what is happening? NaCl plus H2O, because NaCl was present and H2O was present, and what is forming? Hydrogen gas and chlorine gas is formed, okay. And what is left behind? So the anion or the cation which is not used, so anion which is not used is OH, and cation which is not used is Na. They both combine to form NaOH, which is sodium hydroxide, right, which is a base, okay. So what will be left in this beaker? Sodium hydroxide will be left. So this is the overall reaction taking place in this particular electrolysis of concentrated aqueous sodium chloride. Now please, you can note this down. Okay, so I hope this is clear. Now let's move on. Okay, so before we move on to the next electrolysis, let's first understand what is the effect of concentration. So if Cl minus ions concentration is higher, then chlorine will be deposited, okay. And if OH minus or hydroxide ion concentration is greater, then oxygen will be deposited, right? How? Let's check. So there are 3 cases. In first case, if we are doing electrolysis just for molten sodium chloride, this is molten. So no water is present, no H plus or OH minus ion, no competition. So simply there are two ions, Na plus and Cl minus. Okay, Na plus or the metal ion will always be deposited at cathode, and at anode non-metal, which is chlorine. Okay, because we do not have any other ion to compete with them. Okay, next case, if we are using concentrated sodium chloride solution, basically the one which we have done previously in the previous slide. So in this case, this is NaCl. Concentrated NaCl solution means that water is present, it is dissolved, but at higher concentration. Basically, Na plus are in greater concentration than H and OH minus. In this case, what happens for cations or for positively charged species, we have to check which one is least reactive. So hydrogen is least reactive because we have checked the reactivity series. So hydrogen gas will be produced at cathode. Okay, and the concentration of which anion or negatively charged ion is greater, that will be deposited at anode. Okay, so in this case, because they are saying concentrated sodium chloride, it means chloride ions are greater in number than OH minus. Hence, Cl minus gas will be present at anode. I hope this is clear. Concentration plays a very important role to determine that what will be actually present at that particular electrode. Then we will talk about dilute NaCl. Dilute NaCl means NaCl is dissolved in water but in less amount. Okay, so greater amount of H and OH minus ions are present, greater amount, and less amount of Na plus and Cl minus are present. Now again, if we have to check for cation, we will check the reactivity. The one which have lower reactivity, that will be deposited at cathode. So in this case, NaH plus has less reactivity than Na. So H will be deposited at cathode. And for anion, we have to check the concentration. So which one is greater in concentration? Over here, it is dilute. Hence, water is greater. Hence, OH minus will be present at anode. And how OH minus will lose electron to give oxygen? This is the reaction. Okay. So oxygen will be produced at anode. I hope this is clear. Please take a minute here and you can write this. Okay, now let's move on. Let's understand few rules with which we can determine that what ion will move towards cathode and which one will move towards anode. Okay, so here we are doing rules for ion discharge at the electrodes. Before that, we should know what is the reactivity series. So the arrangement of metals in a way that shows increasing or decreasing order of their reactivity, that is reactivity series. Okay, so as we go above, the reactivity increases. So basically I can say that potassium is more reactive than lithium, okay, or potassium is more reactive than magnesium, right? Now how do we learn this reactivity series? There is a mnemonic. Okay, what is the mnemonic? Please stop calling me a careless zebra. Instead, try to learn. Instead, try to find out how copper and gold is found. Okay, how copper and gold is found. Okay, now the initials we have to check. P, please of P is equal to P of potassium, right? Similarly, this way you can learn calcium and calling me and magnesium. So you can also write this thing down. It will help you to memorize the reactivity series, right? Mnemonics help us to understand and to memorize things easily. Okay, and this way we do not forget about it. Now, when we talk about cathode, cathode is nothing but the negative electrode, okay, in which the battery pumps the electron, okay. So at cathode, what will come? At cathode, positively charged ion will come, okay. And for positively charged ion, what is the rule? The positively charged ion or the metal ion or hydrogen, the rule is simple. You have to check the reactivity in the reactivity series. Whichever lies below, that will be deposited at the cathode. Okay, easy, simple. So whichever is less reactive will be discharged. Okay, as they will accept electron more readily. Accepting electron means what? What do you mean by accepting of electron? It means reduction. right? It will accept electron easily. So this is the understanding of how or which metal will be deposited at cathode. Okay, so silver is most likely to, then copper, then hydrogen, then zinc. Okay, so as we go up in this reactivity series, as the reactivity increases, lesser is their chance to get deposited. Okay, so remember just one rule for cathode: whichever metal is present below, that will be deposited. Okay, now let's talk about anode. Anode is the positive electrode, or I can say that negative ions will come to it. Now for negative ion, we have already discussed in the previous slide. Whichever negative ion concentration is higher, that will be deposited at anode. Okay, that will be deposited at anode. Let's read. If the ions of a halogen Cl minus, Br minus, I minus are present in high concentration, then that will be depositing. Okay, they will give up electrons. Giving up electrons means what? Oxidation, right? The OH minus ions remain in the solution. If no halogen, if there is no halogen present, or halogen is present in lesser amount, as we have discussed here. Okay, here there was no here dilute NaCl. In this case, OH minus was in less amount and Cl minus was in greater amount. No, in concentrated the Cl minus was in greater amount. Okay, second one, therefore chlorine gas was produced. Okay, similarly in these rules also they are saying that when OH minus ions are discharged, oxygen is formed. Sulfate and nitrate ions are not discharged in preference to OH minus ions. Okay, this is the preference. Now please take a minute here and note this down. I hope the rules are clear to you. Now let's try a few examples. Okay, so we have this table with us. Electrolyte solution is given to us. We have to identify which product will be formed at cathode and which at anode. Okay, try to do without looking at the answers. Now the first one, concentrated NaCl. Concentrated NaCl means NaCl is present at higher amount or higher concentration than water. It means that H and OH minus ions will be present, first of all, because it is concentrated. Aqueous, right? So definitely from cation, hydrogen will go, because hydrogen lies below in the reactivity series, below sodium, right? So hydrogen will definitely be produced at cathode. And what about Cl minus and OH minus? Because it is concentrated, therefore Cl minus is greater in concentration, hence chlorine gas will be present, right? I hope this is clear. Next is concentrated KBr or potassium bromide. In this case, what happens? So K is potassium, and we can see that potassium lies here above hydrogen, hence I can say hydrogen gas will be produced. Okay, so hydrogen gas will be produced at cathode, definitely, yes. And what about concentrated Br? Concentrated Br means halogen is present at higher concentration, hence bromine gas will be. Okay, next is your dilute NaCl. Dilute means water is at higher concentration and NaCl is present in lower concentration. So in this case, again, these ions will be present competing with these ions. Positive, in positive case, we have to check the reactivity. So hydrogen will be produced, and in negative, we have to check the concentration. It is dilute, hence OH minus will be reacting and will be forming oxygen, hence oxygen will be produced. Dilute KBr, again the same thing, H plus and OH minus. Who will win? Definitely H plus will win. So hydrogen will be produced at cathode, and Br minus is in less amount because it is diluted potassium bromide, hence OH minus will lose electron to produce oxygen. Okay, next is lead bromide. We have done this in the first slide itself. So lead is a metal, and this is non-metal. No water is present, just lead bromide concentrated. So we can say lead will be deposited at cathode and bromine gas will be at anode. Okay, now let's move on. Okay, so now we will be discussing about electrolysis of blue copper sulfate solution using graphite electrodes. Okay, there are two electrolysis like this, one with graphite electrode and then with copper electrode. So don't get confused. First we will be discussing about the graphite electrode. So far we have discussed the examples of graphite electrode only. Okay, so these are the graphite electrode. Copper is less reactive. Okay, so what is actually happening? Copper sulfate. Here, this is the electrolyte. Okay, and copper sulfate will be present. Electrolyte is copper sulfate only, CuSO4. So I can say Cu plus 2 ions, Cu plus 2 ions, and SO4 minus 2 ions will be present, right? Correct. Along with water, right? Water ions will also be present. It means H plus ions will also be present, and OH minus ions will also be present. Correct. Now what will deposit? Let's check. We know copper and hydrogen. Let's check the reactivity series again. The mnemonic you already know. So in this you can see copper lies below hydrogen. So definitely copper is going to deposit. Okay, not hydrogen, but in this case copper will deposit. Now read it. Copper is less reactive than hydrogen, and therefore it is the copper ions that are discharged at the cathode. Okay, this is cathode. Here you will not see hydrogen, you will see copper ions getting deposited. Okay, at cathode. Now what is the reaction taking place at cathode, or what will be the cathode half reaction? So copper gaining electron, because cathode is negative electrode. So it will gain electron and it will become neutral copper. Okay, this is the cathode half reaction. Okay, it is gaining electron, basically reduction of copper will take place. Okay, reduction of copper will take place, not hydrogen. Remember this, because copper lies below hydrogen in the reactivity series. Okay. Next, what will be happening at anode? Now at anode we have two ions to compete with, OH minus and SO4 minus 2. In the previous slide itself, I told you that the probability of OH minus is greater to be discharged than SO4 and NO3, right? So definitely hydroxide ions will be deposited over here. Let me write OH minus ions will be present over here. Okay. And if you will do oxidation of OH minus, let us say oxidation of OH. Okay, what will happen? It will lose 4 electron and oxygen gas will be produced. Okay, so here you can see oxygen gas O2, and over here you can see C, metal, right? So this is the half equation at anode, or the oxidation half of this particular reaction. If you will write the complete overall reaction, then what do? We add reaction 1 and reaction 2, or we can say we add the reaction which is taking place at cathode and the reaction which is taking place at anode. If you will add them, you will get this particular reaction, which is also known as overall reaction of this, right? Take a minute and note it. Okay, so I hope this is clear. Now let's move on to the electrolysis of copper sulfate using copper electrode. Okay, so if we are not using graphite electrode, we can also use metal electrode like copper. Okay, in this case what happened? This is made up of copper only, and so is this electrode is made up of copper. What will now happen? Let's check. The anode, however, loses mass as copper dissolves from the electrode. So when we will pass the current in this circuit, what will happen? The anode, the ions which are present at anode, which are Cu plus 2 ions, because it is made up of copper only, right? So it is made up of copper strip only. So the ions will start moving from positive anode and it will start getting deposited at cathode, because cathode is electron rich electrode. Okay, and the copper ions, which are metal ions, are electron deficient. So they are moving towards the cathode so that they can gain electron. Right, so these copper plus 2 ions are going towards electron rich electrode, which is our cathode, and there they will wait. Okay, so here is the reaction. Copper plus 2 moving, copper plus 2 moves. Okay, these copper plus 2 moves, comes over here, gains 2 electron and gets neutralized. Okay, and they form copper metal, and this metal gets deposited over here. Therefore you can see that this strip is getting thinner and this will get thicker. Why? Because copper metal is getting deposited over here. So remember that from anode the copper ions move towards cathode to gain electron. Gaining electron means to get reduced, okay, as copper metal. And the rest of the things like CuSO4, how will we break it down? Cu plus 2 plus SO4 minus 2, and about H2O, H plus and OH minus. Rest of the ions like H plus, OH minus and SO4, they will be present in this solution only. right? They will be present here only. Now, what will be happening at anode? Because anode is positively charged electrode, what will happen? The copper will come over here, hence it will lose its electron. Why? Because it is already electron rich, it doesn't have any charge over it, right? So copper will come over here, lose their electron at anode. Losing means oxidation. Okay, it will lose their electrons over here, and then they will move towards here, gain electrons again, and then coming back. In this case, what is going to happen? So overall, there is a transfer of copper from anode to cathode. From anode to cathode, the color of the copper 2 sulfate, okay, the color of copper sulfate is blue, okay. Color of copper sulfate does not change. Why it is not changing? Because they are just moving, okay, they are continuously moving in the same cycle. So why will the color change? Color change will take place when one step is not reversible. But here it is reversible. What is happening? Copper plus 2 ion moving towards cathode, getting deposited over here. Then copper comes here, lose electron, becomes cation. Then again it moves to cathode to gain electron and neutralize and to get settled or deposited. Okay, so the same thing is happening again and again. Hence, there is no color change. Why I have mentioned this line in this particular slide? Because this question have been asked in your previous past paper. Okay, so color will not change, color will remain the same. The idea of dissolving anode, okay, so the idea of this particular setup is to purify copper. This is how metals get purified. Okay, you can imagine a strip of impure copper over here, impure copper over here. What will happen when we will pass the current? The copper ions, only the copper ions will move towards the cathode. Only the pure copper ions will move towards the cathode. They will gain electron, and the mud or the sand or whatever impurities was present will be deposited here, okay, below this, below the anode. Okay, this is how we purify metal. Okay, this is a this is the method how do we purify copper or any metal. Okay, so now take a minute. This purification is also, the process is also known as electroplating. We will discuss electroplating in detail in the third and the last part of your chapter, which is electrochemistry. So as of now, just understand this and you can write this thing down. Alright, I hope this is clear. So here we come to an end of your part 2 of electrochemistry. I hope you enjoyed it, and this really helped you to understand the concepts in a good way. If you have any doubt, feel free to comment down below and I'll get back to you. And till then, keep learning and watch out for our part 3 as well. It will be coming soon, and keep learning and enjoy. Thanks for watching, and I'll see you in the next video. Till then, don't forget to like, share and subscribe to our channel.